All right, hello guys. I think the audio on this one is going to be pretty good. I did some tests. I think the microphone is working properly now. But this video is not going to be about me achieving something good with the audio. It's going to be about the encoder. I said I was going to make a video about it. This video is, I hope it serves two things. One is more or less tell you why I built it, and if you're not an encoder operator yourself and you're curious. And the other one is for the people who are running one to know exactly what's happening in the black box. What is this piece of software doing? I shared it in other videos. This is my encoder operating Snappy. This is basically the front end, the dashboard, so I can more or less see what's going on. If there's mistakes and stuff, I can see them. I can check the logs. It's just beautiful to have. Makes operating this painless, which is one of the goals. But anyways, let's talk about the design and why the encoder was a big challenge. And the first challenge that I took on when I first started working for ThreeSpeak, when I'm working with ThreeSpeak, I shouldn't say for, working with ThreeSpeak. So you might know this, you might not, but the encoders have existed for a while. As a matter of fact, it was one of the key pieces of software that Vaultec did for the Speak network some years ago. But as it happens with all software, if it's not maintained, things begin to break. When I jumped in to work with ThreeSpeak, one of the things that had happened was that nobody was running encoders except for Sagar, which is one of the Hive witnesses and developers that we have. And that wasn't the idea of the system. The idea is to decentralize encoding. But it was difficult to implement. A lot of things had to do with compatibility, so you had to get in there, change packages and what have you. Again, if you don't maintain software, things eventually break. So I tried, and I tried for days to fix that encoder, to update it. But I was having a real hard time, and it was a skill issue. I'm not going to go ahead and lie and say that, oh no, it was a skill issue. I had such a hard time making it run properly. It was connecting, it was requesting jobs, but then they would fail, and I couldn't figure it out. And I thought, and then I learned there was a lot more things that I needed to address. But then I thought, okay, no, I'm just going to make my own. Maybe that was crazy, maybe that was dumb, but I don't regret it because I learned a ton from creating my encoder, and I think I also created something that is a lot easier to use and a lot more resilient because it has a lot of fallback. So it's basically designed to survive a lot of issues with the system. Obviously, there's going to be a lot of things that are completely out of scope, meaning they're not here. We're just going to pretend they exist. They're somewhere out there, and then I'll try to do my best to explain more or less what it does. But here we go. So you basically have two main things interacting at all times. The encoders, which in this case we're just focusing on one. Let's pretend this is Snappy. This is my encoder, and an encoder gateway. The encoder gateway is another piece of software that Vaultec did, that what it does, it assigns jobs to encoders. So encoders, they go online, they do a handshake with the encoder gateway through a unique key, also referred to as DID, which is one of the things that you have to set up in your encoder so that we can clearly identify what encoder you are, and what have you. If not, it generates a brand new one every single time. So you want to save it. That's part of the instructions. But anyways, I'm going in a tangent. So it connects to the encoder gateway does a handshake, and then it starts to pull, if you will, request from the encoder gateway jobs. Hey, do you have something for me to do? Hey, do you have something? So this is the two arrows you see right here. Obviously, if there's no jobs, nothing's going to happen. But if there is a job, then the encoder will get the information it needs to begin working. So how does a job look? Well, the payload for the job has a few details, but the most important one is something that you're going to see a lot in the world of IPFS, the Interplanetary File System. That is the name, I promise you. A lot of videos about IPFS. Maybe I can make one about IPFS, but there's guys out there that have made awesome videos, and that's where I learned from watching theirs. At any rate, as long as the encoder receives a payload that has the information, like who the job belongs to, so who's the user that you're doing the video to, the perm link, which is also connected to Hive. So like basically that with those two, you can create the URL so you can go see at the post or generate the post on ThreeSpeak, which we can talk about some other time as well. With the perm link and the owner, the username, and a CAD, and then more information on when it happened, timestamp, and all the stuff, progress, all those good things, and a state. But what really matters about that is the CAD. Now, the first thing the encoder has to do, this is the first thing it has to do after it receives the job, it puts it on queue. So there's a list. Right now on Snappy, there's only one, but there can be a bunch here. So there can be a lot of work, and there can be a bunch. Obviously, the more encoders we have, the faster the encoding, because they're not going to be overloaded. It's not going to be people waiting. It's the load is distributed by the gateway, by the encoder gateway. That's the idea. But at any rate, then it's the first thing it has to do is download the job. What does that mean? It has to download the raw file that somebody uploaded to the system. Now, how it downloads the file, it can be in many, many different ways. In ThreeSpeak, we have and if you've seen any other video of mine about this, you've seen this too. We have a very gigantic, powerful server we call the supernode, and there's a IPFS gateway running there. And what I mean by IPFS gateway, because I realize I'm calling this an encoder gateway, is an HTTPS, something you can put on your browser to access CIDs, to access unique identifiers for files. Now, one of the things about IPFS that is important to understand in order for this to make sense is that every time you pin something, you add something to the IPFS system, that in turn gives you back a hash. And it's a unique number that will only refer to the one thing that you added to the IPFS. So it's not based on address. It's not on a URL. It's not like if I have, let's say, just for the sake of arguing, I upload a video and my hash, obviously this is not the hash, but just to make my point clear, is ABCDE, right? That's my hash, okay? Then I don't need to know where the video is. It could be anywhere. It could be here. It can be in China. It can be in Spain. It doesn't matter. If I try to reach that CID by either using an IPFS protocol, which I put down here, or using any public gateway like this one here, I can. In other words, if I was to type https://ipfs.threespeak.tv/ipfs/abcde, then my video would show up, even if I uploaded it from China. Doesn't matter. It hardly matters. I could pin it to my computer. If my computer is connected to the internet, if I have a IPFS daemon running on this computer, and I pin it to my computer, and so it announces, it kind of propagates, and somebody in Europe wants to see the video, it will find it. It works very much like torrents do, like seeding. Like if you don't know what that is, then you are a protected child. It's just like torrents. So anyways, now, so the first thing it has to do is download the work. This is one of the bottlenecks or the fallbacks that I implemented. It first attempts to download it from ipfs.threespeak.tv. This I'm changing. So in the new code, there's going to be a new gateway. We're not going to rely on the supernode. The supernode tends to get overwhelmed. We're going to be using the staging server, but that's a topic for a different video. If it cannot download it from the HTTPS gateway for any reason, then it downloads it using your local Kubo IPFS daemon. What does that mean? It means just like you would in the terminal, if you were to use your Kubo daemon, you could look at a video, you could retrieve it, you could do a curl, just like you do a curl for a website. You can think of it like that. You can retrieve or pin locally something that somebody else has. So what it would attempt to do is like, okay, I cannot download it from the ipfs.threespeak.tv. It's not working. It's not responding. Well, let me go ahead and pin it locally. That's what it does. And when it tries to pin it locally, right, and it does the pinning, then it's going to broadcast to the network, hey, I need this work. I need this job. Well, the network doesn't know. It's just, I need this CID. I need this unique identifier. Give it to me. And then the network starts to talk. All the nodes that are running all over the world are talking to each other. And then one of them responds, say, I have it. And then starts to send it. And then it jumps from node to node until it gets to you. So the first thing it needs to do is download the work. This is an important fallback because the supernode can fail. The IPFS network can also fail. So that's why the encoder also has retries. But again, I'm reinforcing this. Then the next step that it needs to do, it needs to encode the video in different formats. For that, it uses a piece of software called FFmpeg, which is a very powerful terminal-based encoding open source software. So how does it do it? Well, it determines what it needs to do. If it's a short, it probes the video, says, okay, this video needs compression or doesn't need compression, or it needs a conversion because it's a MOV and MOVs don't work on browsers sometimes, or it's an HVEC. There's some formats that are not compatible on browsers, so it does a probe to more or less have a plan of attack. And after it has a plan of attack, then it begins encoding using FFmpeg. One of the things that I am still yet to crack, and anybody's welcome to contribute, is hardware acceleration without killing the computer. I have some hardware acceleration. I know some of the guys have been able to use it if they got GPUs. Issue is I don't have GPUs, so I can only use CPUs to encode, which is fine, I guess. But if you are interested in helping me out, I have a hardware test. Extracted the code from my encoder to see if I'm detecting GPUs correctly and if I'm using acceleration correctly. So shout out to Lewis because he's helping me out with this as well. But after it does the encoding, then it needs to create what is called an HLS structure. An HLS structure has been around for a while, but what it is basically a multi-format, and what I mean by that is multi-quality. I'm sorry, not multi-format, multi-quality folder structure. So there's a main folder, right, with a manifest that directs, it's like a text file, that directs what quality lives on what folder. And there'll be a 480, a 720, and a 1080, obviously different qualities. Now, why do we need 3 different qualities? As a matter of fact, we're probably going to end up adding more eventually in the future. Because it really depends on your speed connection. Some people have very slow internet, so you're going to deliver, and the player does this, by the way, Snappy Player. Out of scope for a conversation, but the Snappy Player does this. It detects your speed, right, the speed of your internet, and then it delivers to you the best video for your circumstance. So if you have fast internet, you're going to get 1080. If you have crappy internet, you're going to get 480. That's kind of the idea. So it creates an HLS structure, right, and it uploads all that stuff to the final storage. So obviously there's more stuff going on here, but just for the sake of this explanation, we're going to leave it there. And once it finishes uploading that whole thing, so it's recursive. It has to upload every single file that is inside all those folders and the folder that contains that folder. And if you ever see an HLS structure, you're going to see that inside it has tiny little segments. And why is that? Well, it has to do with how the buffering works and how you can slide back and forth to go, minute 1, etc. And how it fetches. It fetches ahead of time so that you can continue watching videos without stalling. That's why it does it. So then it obtains a CID after it does that. So it's a brand new structure. It gets the CID, and then it communicates with the gateway and reports that the job is completed. And then the encoder gateway takes it the rest of the way. So anyways, so the encoder has to work, I guess you could say, along 2 more programs, as I said. This is a key thing about this. One of them is the Kubo daemon, which I did not put here, but it's always talking to the Kubo daemon, and I explained why. It uses this to download files if it needs to, and it also can use it to pin files locally, and this is a fallback that the encoders have, and I'll explain that here in a second. But it's always it needs to, so in order for the encoder to run, it needs to have a Kubo daemon running on the same server as well. So part of the dependencies of a super encoder is the Kubo, FFmpeg, and of course Axios and other stuff that I use that if you run the script, it's going to install automatically for you. Now, this is a broad overview, but I want to tell you guys about a few more things that I built into the encoder that I think are pretty cool. So the first one is the ability to force processing. This is something I built, and it's only for ThreeSpeak infra encoders. So what does this do? We have a complete outage, meaning that I don't know, like somebody's connection is bad, or there's like 3 or 4 jobs that are stuck for whatever reason. Either Eddie or me or anybody that has access to my encoder can grab the job and force the processing, and that's gonna completely bypass the gateway, this thing that I was describing earlier, completely bypass it, and just get the job done. It's like I also call it tank mode or juggernaut mode sometimes, because it doesn't matter. It's like it's just going to ignore everybody. It's like, oh, let me grab the job, I'm going to encode it, let me upload it, done uploading, here we go, and it updates the database and it pushes it to Hive. Like no nobody's stopping. It's not going to stop because if somebody else had the job already, or like, oh no, it's been an hour, let's wait for the healer. Nothing. It's just juggernaut. Let's go right through. So that's one of the cool things that I've implemented as a crazy fallback. The other thing that I implemented is this, which is an IPFS management. So what is this all about? Again, this is only for ThreeSpeak infra. No, you can actually any encoder, any person that has an encoder, doesn't have to be ThreeSpeak infra, can also do IPFS storage. So like as I said earlier, you have in your encoder in the software that you're running on the encoder, you have these programs already. So you have Kubo and you have FFmpeg. Now this is basically an easy way to use Kubo, looking at Kubo. So and this is because the encoder has another crazy fallback, and I wanted this to make it easy to do. So if at the stage of sending it to the final storage, so let's say that it does all this, it gets the job, it encodes it in different formats, it creates a structure, and it's attempting to upload it to the final destination. Okay, this is where it's going to go, and it's not successful for any reason. It cannot upload it. It's trying, and maybe the super node is not responding. Now we have the hot node. The hot node is beautiful and fast, so it's always working. But let's say, and we have fallback. So it first tries to do the hot node. If that doesn't work, then it tries to do the super node. And if that doesn't work, which is the nuclear option, then it just leaves it on the local hard drive, which is this right here. So what does that mean? It means exactly what I meant, is that it's going to pin that structure, the whole folder, to the local daemon, the local Kubo daemon. All the pins you guys see here in this list are folders containing videos of people that are watching on ThreeSpeak. All these pins right here. And then what it's going to do, which is I think the coolest part, it's going to migrate all these pins. So all the ones that are pinned locally on the Kubo daemon, it's going to migrate them to the final storage. I call it lazy pinning. So by finishing the job, remember how I said that IPFS doesn't care where the video is, because its direction, it only cares about the CID. So it doesn't matter where it is. So that means that if I pin it to this server, right, to Snappy, and I tell the gateway, hey, I'm done with the job, you're going to be able to watch the video. Because you're going to be on ThreeSpeak, and you're going to say, hey, I want to watch the latest video that MenO made, and then ThreeSpeak is going to be like, hey, I want this CID, this is the video I want to watch, and then Snappy is going to respond through the IPFS network, hey, I have that video, and I have that CID, send it to the server that is trying to watch it, and then you watch the video. So, and then this is going to slowly migrate the video. Obviously, I have a way to do it manually as well. For example, here I can check, this one is 81 megabytes, and I can migrate it to the supernode, which is where they go live, and it says syncing to supernode, syncing failed, timeout, storage means. So that one, that's lazy migration. It's migrating pin to the supernode. There you go. So it migrated. Pin verified on supernode, successful. So now this pin here that I just moved, this one I can already delete. So I can unpin it from Snappy, right? And I can also run what's a garbage collection. And this garbage collection is going to delete anything that is not pinned. Now, because that is migrated to the supernode, that's it. Nothing else needs to happen. And when somebody wants to watch a video, the player, Snappy player, is going to request that CID, and you're going to be able to watch it. It doesn't have to be here because it's already somewhere else. Now, another thing that I love about this is that this runs on autopilot. So if you have a fallback like this set up on your encoder node, without you doing a thing, if videos fail to upload for whatever reason, most of these videos are because we had an outage a few days ago, then it's going to pin them locally. It's going to report the jobs to the gateway. You're going to be able to watch the videos. It's going to migrate them with something I call lazy pinning. When it doesn't have work, it's like, I have nothing to do right now. Let me go ahead and start moving these videos. Then once it has migrated those videos to the supernode, then it's going to unpin. Again, all this is running on autopilot. Unpin the videos that are already migrated, and then run a garbage collection and free up hard drive from the encoder. So I think that's pretty awesome. It's a fallback to the fallback to the fallback, and I love it. Anyways, I think that's going to be it for this video. I hope it clears up how the encoder works and how important it is to understand what Kubo is doing. How when you download things through your internal Kubo, like you're just requesting it from the network. It's not that, oh, if it's not on my hard drive, it doesn't matter. When I request something because I'm requesting from the CID, then I can get it. As long as I am connected, and I have peers and all this stuff. I could make a video about IPFS. If that sounds interesting, let me know in the comments. But I think this broad overview of the encoder is, well, I hope it's going to be helpful. Anyways, that's it for me. This video already went too long.